Thanks for coming, and thanks to QCware for inviting me to speak at Q2B. I'll start with a slight correction. I'm principal specialist, and I'm specializing in not being a scientist. So I actually do business development and go-to-market for AWS Quantum Technologies. So today, I thought I'd just take us through sort of an update on what AWS is doing, how we're investing in quantum technologies, what we're doing with our customers, with our partners, give you some customer stories. You'll see a lot of familiar names and faces in these slides. People have been presenting over the last day and a half, and hopefully next year we'll see some more from this room. So AWS has been actively investing in quantum technologies for almost 5 years now. Simone Severini really kicked things off with this pilot activity that covers these 5 areas. The reason being initially that the senior management team was fielding questions from our largest customers about what is this stuff? We don't understand it. What do we need to know about it? What do we need to prepare for in terms of impact on our businesses? Can we take advantage of it? What's the timing? So tons of questions, tons of uncertainty. This is now, 5, 6, 7 years ago. And so the decision was taken to sort of start to invest to try to help our customers understand, essentially. And that takes the form of these 5 sort of pillars. There's a couple of R&D teams. The Center for Quantum Computing is at the Caltech campus. It's an AWS building and team on Caltech campus. They're building qubits. The Center for Quantum Networking is a collaboration with Harvard. They're looking at networking communications hardware. The Quantum Solutions Lab is a professional services team, so they engage directly with our largest customers and do collaborative research that usually these days it ends up being a classical solution. The focus is often a production solution, and therefore it's classical, but they learn about quantum algorithms, quantum information science along the way in those engagements. Of course, the partner network is across AWS, but we have a dedicated team for our quantum-focused partners, so ISVs, service providers, and our hardware partners. And then Bracket is our main sort of go-to-market mechanism. It's a cloud service, which I'll talk about some more soon. I mentioned CQC. This is sort of the most recent update. We don't have hardware in the market. We don't have hardware that our customers are using. They're still working. They're sort of in the early R&D stage. But at reInvent this past year, Peter DeSantis provided an update, and they're looking at a type of cat qubit, so another instance of Americans copying the French, Alison Bob, I guess. But they're progressing very nicely. It's a very good team, and that we're anticipating that'll be available in the future. The Bracket service, I mentioned, this is a full lifecycle service. It's fully integrated with the rest of the AWS cloud, which is really important to our customers. It supports the entire life cycle of building circuits, building experiments, testing them on simulators. There's a local simulator in the SDK, and there are also managed simulators, which are quite large in the cloud, 34 qubits on the state vector machine simulator, and I think 50 or almost 50 on the tensor network simulator. Running the circuits, of course, across a variety of different pieces of hardware, and then analyzing the results. Of course, the data is all on AWS, so you have all the normal tools for managing and analyzing your results. The goals behind Bracket, by the way, I joined AWS in 2021. I joined from IBM Quantum, where I was managing the academic research partnerships in the researcher program for a number of years. I was really attracted to the Bracket service because I could see that the agenda was, as you can see here, really trying to take a lot of the friction out of the market. AWS is fond of flywheels, which I think they're a good mechanism because when you can make them work, you really can get a lot of multiplicative effects in the market. Democratizing access to quantum hardware was sort of step 1. So providing a single interface, a single service that could provide access to a number of different devices without having to learn different technology stacks. Makes code more portable, makes skills more portable, makes the investment in any one particular hardware device lower for our customers. the providing choice and staying open-minded is really not having a set idea of what the bracket service was supposed to be when we launched the bracket service. So we have a number of tenets that guide the design of the service, but the service is evolving continually. So, we've introduced CASM-3 support a little over a year and a half ago, pulse control about a year ago, verbatim compilation, a number of other features, hybrid jobs, and others. All of them have been in response to what our primarily research customers have been telling us they want in order to get high quality interaction with the hardware on the devices. So it's continually evolving. And then the sort of final stage is helping our customers. I said the initial impetus being a customer request for clarity and information. We try to help them sort through what are the reasonable expectations for the hardware, which can be very, very difficult to assess when you're not immersed in it as we are. Even for us, it can be difficult to assess exactly how important one particular paper or breakthrough or article may be versus another. So we invest a lot of time through our scientists in trying to sort that out. As I mentioned, choice of different hardware. This is what's currently on the service. We've got IonQ's Harmony and Forte devices, OQC's Lucy device. Rigetti is actually, we're between devices for Rigetti at the moment. We had the M2. We're deciding with them on what device they want to add to the service next. QAero, we've got the Aquila system. So at the moment we have ion traps, superconducting, and Rydberg atom or neutral atom arrays. There's a number of other vendors who will be joining this year. Or this year or next year. The roadmaps are always uncertain because these devices are very idiosyncratic, and also all these vendors often refresh their devices. So it's a constantly changing lineup. I talked about clarifying, so this is an example recently, just this fall. It's a great paper. If you haven't seen it, I highly recommend it. It's a collaboration among our scientists from the CQC, the science team within the bracket service, some of our field scientists, and the professional services team. And it's a really huge survey of all of the identified quantum algorithms that breaks out the primitives that go into building up that algorithm for an end-to-end solution and does a lot of resource estimation. So it's also, I've never seen anybody do this, but it's a PDF that's structured like a wiki, so you can click on the titles and you can pop around. It's a really great reference tool. Okay, now the customer stories. That's sort of an overview of where we are. So there's a combination here of private sector and public sector. This is a research paper that we helped Goldman Sachs with. They've been obviously a pioneer in this space for quite a long time. And they were looking at this is almost an offshoot of that previous paper that I mentioned, another end-to-end resource analysis of the interior point methods for portfolio optimization. And very similar to the paper, actually, the outcome was promising. However, there's a lot of externalities, a lot of classical pre-processing state preparation, et cetera, and overheads for decoding, et cetera, that can take away a lot of the potential quantum advantage. So there's a lot more work that needs to be done in optimizing the algorithm, sort of echoing what the previous speaker was saying. If you get more clever with your algorithm, you can get better results. And also looking at that, we're thinking a lot more about end-to-end in the terms of, as we get closer to algorithms and hardware that are going to start being productive, they won't be productive in a vacuum. There's going to need to be classical resources and steps interspersed with the quantum to actually deploy something that is going to produce value for a customer. So we're very interested in questions that sort of try to answer those end-to-end pictures. We do a lot of work supporting researchers. This is a piece of work done by Australian National University about a year ago, I think. This is a good story just because it actually illustrates everything we do with researchers. So it started with some enablement. We helped them understand how they could use Bracket to support their research. We provided, after the training and enablement, we provided some credits for sort of the early stage of the scoping out the experiment. and then supported that with solution architects who had both cloud and quantum experience. The service team actually got engaged because it was one of those situations where the scientists were pushing the limits of what the service could do, so the service team learned quite a bit from this engagement. And end to end, there was sort of a 20-month span from the first engagement to a Nature paper. So it felt like a good outcome for our public sector type of engagement. Another instance, and you'll see here's a familiar face, of a public sector collaboration. This is Elham's Quantum Software Lab at University of Edinburgh, which launched last April in a pilot phase. They're targeting a number of projects over the first 3 years in the pilot, and we wanted to support that. So again, using that cloud credit for researcher kind of mechanism, we've pledged that we'll support up to $300,000 in credits for those projects over the 3 years, as well as enablement and workshop and office hours and all the sort of close collaboration that is required for making the service and the devices productive for them. Quantify, another familiar name. They are using Bracket in the implementation, and actually specifically Bracket hybrid jobs. This is a relatively, I think it's a little over a year old feature, year and a half maybe. You can attach a classical container to a Bracket instance, and that container you can run your own. There's either off-the-shelf containers, or you can run your own custom code in that container. So they've used that to implement their own fast VQE algorithm and interact with the Bracket, the hardware through the Bracket service in this hybrid job instance. So that's the kind of extensibility that the service supports for our ISV customers. Another ISV customer, another familiar name, they're not here, but certainly everybody knows Wolfram. They are using Bracket to expose quantum services within the Wolfram product. It's a very early stage, but they have a circuit builder you can see here, and their users are responding quite positively to it. So for them, and all the ISVs who build on Bracket, it's a way of building to a single interface and sort of not having to choose a single hardware platform when they may need access to more than one, or their choices may evolve over time as the hardware evolves. Another public sector, this program started, 2021. It's a collaboration with the Indian government, and it's actually their applications lab. So it's a very similar pattern to the University of Edinburgh Quantum Software Lab, which, by the way, is a pattern that we're seeing repeating at the sort of national and regional level initiatives over and over again. This idea of a project pipeline that often solicits use cases from industry, and then tries to find a quantum information science approach to solve those problems. And they're quite good for us as a collaboration vehicle because they bring together our customers' questions with the researchers, with the expert users that help us evolve the service. So this was another research credit grant. And at this stage, I think there have been 72 grants to 52 academic institutions and 34 publications to date. And that's actually ramping up at this stage. That was the initial phase. Everything in India is very large scale, and the initial phase is like one of the largest collaborations we have going, and it's only getting bigger. On to sort of product updates. I've mentioned a number of features of the service already. This is the newest one, and it's actually quite a radical change to the service. It's a new form of access supported within the Bracket service. So at launch and still now, the main way that people access hardware is sort of on demand, right? There's availability windows for each device, maybe a certain number of hours each day. When it's available, anybody can log into the console, run a circuit, and they pay for the circuits as they go. Bracket Direct is actually a dedicated access model. So it starts with a reservation. You reserve a block of time in increments of 1 hour. And during that block, you have exclusive use of that device. Especially for things where there's calibration sensitivities, you're running tomographies, there's other use cases where that's really useful to not have other jobs interspersed. But also it comes with white glove service. So there's our own scientists are available to prepare for that 1 hour block, or that 1 or more hour block. and also you can engage with the quantum hardware provider. So that's what's really radically new. We launched with IonQ Forte and QEra. Forte is notable because it's not available on the public service. So you can get access to Forte, which is their top-of-the-line device. It's 32 qubits, all-to-all connectivity, and you can do that with IonQ. So if you're just exploring the device, exploring the service, you may start with Harmony and the on-demand. Once you get a sense of what you want to do, you want to do something really big, really push the limits of what the hardware can do, you're going to want to engage the hardware provider so that they can have their hands on the knobs, as you need to do to tune these things at this stage. That's a really great new capability. And in addition, what we're working on next for Direct is actually being able to allow our hardware vendors to expose beta features, new hardware that's not ready for maybe a 5-day-a-week availability window, but they want to engage with customers privately in like a private beta kind of sense. So there'll be even more sort of cutting-edge features being exposed in the hardware through Bracket Direct. So it's right there in the console now. There's a new tab on the new section on the left. You start by reserving the device, and then you can select from the existing devices that are in Direct as well as the services. You can see on the IonQ tile, for example, there's view services that takes you out to the AWS marketplace, and there's a number of different ways to engage with them, with their consulting services in conjunction with the hardware access. And it provides access to the 30-qubit machine, yeah. Right, and that was, I'm gonna skip because I've got 3 minutes left, and I want to get to the calls to action. So, if there's any researchers out there that want to kick the tires on Bracket, this is a really great program. I've used it in the 2.5 years since I joined. I've given away millions of dollars, which I love doing. It's very lightweight. You don't need a giant proposal, a paragraph or two, and it's quite generous. So I think the average, between like a $5,000 sort of dollar range is pretty average for a grant. I have to bring that to the program and explain to them what's unique about it. So I need to be armed with what you think is really good about the research you're doing. But I really love working with researchers to get their stuff going. We've got a number of learning options. So we do a monthly workshop. The March one just happened on Tuesday, unfortunately. So that date is not very useful to you, but the next one will be coming up in April. This is like a half day online. We try to vary the time so it's a European-friendly or an Asian-friendly time zone. And our essays sort of take everybody through the initial stages of doing some work on Bracket. A really good way to prepare for that online workshop is a new badge that we launched at reInvent. So this is a level 100 class, a level 200 class, and then a skills assessment, and you can get a digital badge. So it's 50 questions that you pass. And then, of course, all of the customer stories I featured, all of the new feature announcements, all the new hardware announcements, those are all on our blog. So that's a great place to learn more. And then, another familiar face, Airbus was up here earlier, BMW's been here today or yesterday. This challenge is building on the BMW challenge that we ran with them in 2021 and 2022. We're really excited about this. You heard, I won't go into detail because you heard the whole story if you were here before, from Jasper and Ashkat. But yeah, they've identified these 4 areas. They're looking for proposals for how to solve these problems with quantum information science, and there's still time to get your proposals in. With the BMW challenge, I think we had on the order of 70 or 80 proposals, and they were all really high quality. There's a lot of great stuff that came out of that. And that's it.
Thanks very much.
Sure.
Thanks a lot, Sebastian. That was very interesting. I think in particular, the Bracket Direct is going to be super useful, personally, from my point of view at least. Yeah. We have time for one question. So concerns about data privacy and security regulations drive the need for an on-premises quantum computing device as opposed to something cloud-based, which you offer. So what's AWS's point of view on this?
I mean, security is job zero, as AWS likes to say. So the data on the service, it's on our cloud has all the regular security that AWS has. The vendors actually own and operate the devices through the public side of the service, and they go through really rigorous security checks and pen testing and all the rest of it. And the circuit itself gets stripped of any metadata. So there's no AWS customer information in the circuit payload, and the agreement with the provider requires them to discard any information about the circuit and the results of the job as soon as they've finished it. So we're quite confident about the data security of the existing public devices, but we also recognize, we've heard about it over the last few days a lot of times. There's a lot of on-premise hardware being deployed. So we're in early stages of discussing with those customers how we can support that, because we recognize the need for a number of different reasons for that kind of on-premise deployment. So I think that we will soon have a way to support that type of deployment as well.